Hello and welcome to my video submission for production project. My project focuses on smartwatch forensics, specifically analyzing Apple Watch artifacts to a paired iPhone. The aim of this project was to investigate how smartwatch generated artifacts can be forensically acquired and analyzed using industry recognized tools, and to apply these findings to the development of a structured teaching resource for digital forensic students. This project combines both a practical forensic investigation and an educational component, allowing students to gain hands-on experience with smartwatch-related artifacts. The main product developed for this project was this smartwatch was a structured lab sheet, which was designed to give students a thorough analysis of smartwatch artifacts. The lab begins with the introduction to smartwatch forensics, explaining how wearable devices such as the Apple Watch generates valuable data, including health metrics, activity logs, and location data. Moving on to the artifact table, this table provides students with guidance on key artifacts and where they can be located within the dataset. For example, as you can see in here, heart rate data can be found within the health database, while location data may be linked to workout logs or the places category within Examine. Moving on to the tasks, the investigation tasks were designed to gradually develop the students' analytical skills. The first task focuses on identifying a peak heart rate event, which introduces students to navigating health-related artifacts. This is then followed by context analysis, where students must identify associated activities such as workouts. The tasks then progress into correlation, requiring students to link multiple artifacts together, which reflects real-world forensic investigation techniques. Optional extension tasks were also included to further challenge students and encouraging deeper analysis of step count data and location-based artifacts. Okay, moving on to the data set that was provided alongside this lab sheet. Okay, students analyzed the dataset using Examine, where artifacts are organized into categories on the left-hand side, such as health data. Let me fix that. Such as health data, messages, and locations, places as well. To just show the smartwatch generated artifacts, I will just show the heartbeat graph. For example, in task 1, students identified the peak heart rate recorded on a specific date by analyzing the heart graph. To do this, students had to examine the graph, and as you can see, you had to hover over different points to analyze the highest value recorded and the exact timestamp of this event. Moving on to the workout log. Sorry. Okay, so this data is then correlated with the heart rate data was then correlated with the workout logs, where students can identify what activity occurred at that specific time, such as an outdoor run, as you can see in the graph here. Location data further supports this analysis by showing where the user was during this activity, such as Ridings Avenue at this specific point. This demonstrates the correlation of multiple artifacts, which is essential in digital forensic investigations, as this can be used to create in-depth forensic timelines, reconstruction of timeline of events. Okay. Let me just go on to the product. The project was developed using the Agile methodology, which was selected due to its flexibility and iterative nature. This allowed different stages of the project, such as dataset generation and artifact analysis, as you can see here, to be revisited and refined based on ongoing findings. During development, several challenges were encountered. These included storage issues during extraction due to USB formatting limitations, as well as device compatibility issues when generating the dataset. Okay, so I just lost my train of thought. These challenges required adjustment throughout the project, which reflects real-world digital forensic investigations, where investigators had to also adapt to technical limitations. Okay, let me just show the lab sheet. Alongside the lab sheet, students were also given a forensic report and the lab slides, which helped introduce them towards the topic. And the forensic report showed the final showed what smartwatch artifacts can create, as this included a reconstruction of timeline events. The teaching resource was also evaluated using a small group of students with prior digital forensic knowledge. Participants were able to successfully follow the lab sheet. Let me just pull the lab sheet up. They were successfully able to follow the lab sheet and complete the investigation tasks. Feedback indicated that the instructions were clear and the dataset was easy to navigate, although some minor improvements were suggested, such as adding additional detail in certain steps. These improvements were implemented to enhance the clarity and usability of the teaching resource. In conclusion, this project demonstrates that smartwatch-generated artifacts can be effectively analyzed through a paired iPhone using forensic tools such as XRY and Examine. The ability to correlate multiple artifacts, including health data, activity logs, and location information, allows for accurate timeline reconstruction. Furthermore, the development of the teaching resource provides practical value by helping students gain hands-on experience with smartwatch forensic analysis. And that's it for my video submission. Thank you for watching, and bye.